name is Dan Hagelin from FDR Design, and today we're going to be going through the RSGe gas filling machine and just kind of taking a look at some of the components and how to calibrate it and how to troubleshoot some certain different parts of the machine. And we're going to go on a little crazy adventure with the helmet cam. I'm going to strap the helmet cam on, and we're going to get right up close and personal with the gas filling machine, and hopefully you can gain a little better understanding of the machine and how it operates as we do this. So we'll just jump right in. On the front of the machine, you'll notice just a basic power button that just turns the machine on and off. The start button, that's going to be for this particular line. The RSGe is a one-line machine only. And then the meter on the front is going to be showing the argon percentage as the unit fills. You can also use it for troubleshooting and calibration as a calibration aid to see when 5 volts in the back is equal to 100%. And then the beeper, which signals the end of the cycle, and the fan, which just keeps the unit from getting overheated as the pump runs for longer time as the units are being filled. Now if we look inside the machine, starting on the back of the faceplate, again it's the power button, and which the contacts on the lower part, and then the middle part is the lamp module. If you ever need to repair these push buttons, you can see on the end here there's a little tab. You just press that down, and then the button will, the whole back of the button will come out. You can change the light there. And then to put it back in, do the reverse, put it back in place, and then push up on that little tab. And then again, the back of the meter, you can see the fan down there. We're going to jump back over here again, and a big part of the stability of the machine is in a stable temperature that the sensor is mounted in, and the sensor is mounted in an aluminum block. You can see that right down here, and the block maintains a 130-degree temperature, and the sensor is becomes real stable at that temperature, and then this temperature controller controls the temperature of that aluminum block. So we want to keep this right around 130 degrees, and it can be plus or minus a little bit, but as close to 130 as possible. And you actually want to measure the temperature of the aluminum block instead of going just by the reading on the display of the temperature controller, in case that's bad. So actually using a contact type thermometer and pushing it right down on the aluminum and measuring the temperature is best. If we go around the back of the machine here, we'll see a couple of the fuses here, fuse bodies, and then underneath that is going to be the pressure switch. As the machine is powered up, one of the first things that it looks for is 60 psi from the argon regulator, and this is where this is what does that looking. If there's less than 60 psi at the argon regulator, the PLC will see that, and it'll cause a fault to happen. And when a fault happens, then the machine won't operate as normal. It goes into protection mode, and then the only way to get it out of that fault mode is to remedy the fault and then clear the fault. And so if we were to turn the machine on, and there was 40 psi at the bottle, then this switch would open, and then the PLC would say that there's a fault, and the only way to remedy that would be to turn up the pressure to greater than 60 psi, and then by pressing the cycle start button in the front, that'll reset the fault. And we can also see on the PLC a number will display a number 3 or a number 4 if there's a fault. Then moving along again with the parts, we'll see pressure regulator, and that's going to adjust the amount of flow of argon that comes into the machine. And then a solenoid valve, which controls the on-off operation of the gas as it comes into the machine and through the machine. Again, down here is the sensor. We've just changed the style of our sensor. You'll notice it's maybe a little taller fitting than before. Same operation as the previous model. Still orange leads, and the orange lead sensors are compatible with only certain revision of the amplifier boards on the back of the machine. It would be 1.68.01A or K. K for krypton, A for argon. We'll see a vacuum relief adjusting knob on the back here, and then a vacuum gauge which shows inches of mercury, inches of Hg. This is going to be a 24 volt transformer, so it's taking 110 volt line voltage and stepping it down to 24 volts DC, and that's what we use for the control of the PLC and for the solenoid valves and the beepers and the lights. So 110 comes in the bottom, and 24 volt comes out where the solid red and white wires are right here. Over here we have the solid state relay, which is going to turn on the vacuum pump, turn it off and on, and then this is the vacuum pump here. On the front of the vacuum pump, you'll see a little glass canister, and the glass canister is just to collect any kind of debris that might get sucked in through the lines. And then the vacuum switch, and this also is another, it's going to be sensing the vacuum this time instead of the pressure like the other switch was. And if there is no vacuum pressure after the machine has been started, then this will signal to the PLC that there's no vacuum. There must be a problem somewhere. So let's shut the machine down to protect the operator from exploding glass, and that's the main reason for the fault conditions, just to protect the operator from exploding or imploding glass. So this is the vacuum switch, and that brings us around to the front of the machine again. You'll see some more vacuum lines and some argon hoses. The main thing to check with the hoses is that they're not burned or kinked, and occasionally you'll want to pull them out of the fittings and just check to make sure that the end of the hose isn't dimpled. Sometimes the O-rings from the fittings will cause a dimple around the hose, and then could cause leaks there. So you want to check those occasionally, but it's not a huge problem. Back of the machine, we'll notice a couple key components, and this is where a lot of the work gets done on a regular basis with calibration and changing fuses if they might blow, or adjusting the pressure. And we'll start on the left here. This is the argon amplifier board, and you can possibly see the revision 1.68.01A, and the A again is for argon. We can set these up for different types of gas. Over here is going to be the sensor override switch. So when you're doing the calibration, you want to throw this in the up position, and that'll keep the machine from beeping at the end of the cycle. It'll keep it running so that you can do the calibration. And this is the PLC. On the left side we have all the inputs, so it would be our push buttons and our pressure switch and our vacuum switch, and then the argon amplifier board coming in here. And then on the right side we'll have our outputs, so it'll be our solenoid valves, our horn, our lights, and down here these switches should just remain in the on and run position. There's no reason for them to be in any other position. You'll see right now there's a number 3 displayed on the PLC, and if you were to read this little sign, it would say 3 no argon, 4 no vacuum. So right now it's seeing that there's less than 60 psi on that pressure switch, so it's giving me a number 3 fault. And then you can also see Y1 is flashing, and Y1 is the start light for on the front of the machine, and the light flashes when there's a fault. If we move over, we'll see the argon regulator, and this is going to regulate how much argon is actually going out of the filling lance, and so we'll want to turn this up or down. As we're doing the calibration, we'll go through that. This is going to be the argon inlet, so I'll connect our argon to that, and then this is just a vacuum vent, so as the gas comes through the vacuum pump, it just comes out of this, just to vent into the atmosphere. And then up here we'll have the fuses, and they're just standard glass bus type fuses. Okay, now the next thing we're going to do is walk through the steps of calibration, and for that we're just going to need a voltmeter, and we're going to need gas hooked up to the machine, and I have that over here, and we're also going to need this test jug with the magnehelic. We'll use that a little bit later on, and a screwdriver. So the first thing that we're going to do is put the sensor override switch up, because we don't want the machine to beep at the end of the cycle. We want it to keep running. So we'll put that up. And on my voltmeter I have some fancy little alligator clips, and that makes it a little bit easier as I walk through this, just to leave the voltmeter connected right to the alligator clips there. So I'm going to put my black lead into my voltmeter on the common tab, the common plug, and then my red lead is going to go into the volts MA tab. Black on the machine will go to the solid white wire, which goes to the common terminal on the amplifier board, and I put just a little short piece of wire in there again just to help me as I'm going through this. And then the red lead is going to go on the very bottom of the board. You'll see a little metal tab sticking out down there, and that's what I want to connect this to. So I'm just going to hook this right on there, right on that little metal tab. I want to turn on my voltmeter and set it to 2000 M on DC volts, and what that's going to do is display millivolts now. So now I'm looking at 38 millivolts is what it's reading. And as we go through the calibration, you'll see this number change, but for the first part, the first adjustment, we're going to want to set this right around 13 millivolts, and you can be plus or minus a little bit there too. The big thing is that it's a steady number and it settles down, it's not jumping around. To set the air voltage, first thing that we're going to have to do is just take the lance and just let it hang free in the air. We don't want the machine sensing any argon at all. We just want the argon blowing right out into the air, and vacuum just sucking air in from the room. If we were to look up close at this one hole filling lance first before we start the calibration, you'll notice two hoses. The bigger hose is a 3/8 inch outside diameter hose, and that's where the vacuum is going to be sucked back into the machine. And the smaller hose is where the argon comes into the window or out of the machine. And if you look at the tip of this lance, you can see a little slot burned in, and that's where the vacuum gets sucked in. And then out of the center of the end, there's a small hypo needle, and that's where the argon blows out. This lance is for one hole filling, so we only need one lance in the spacer bar, and the argon is blown in real rapidly. It churns and it stirs up the gas inside there, and the vacuum sucks out the air. And after this exchange is done for long enough, then the unit will be filled, and the machine will sense that because it's looking at the exhaust gas, and the machine will beep and it'll shut off, and then the next window can be filled. So to go back to the calibration, what we want to do now is start the machine with the lance just in the free air again, and we're going to adjust the zero pot to 13 millivolts. And we'll just do that with a little screwdriver, and we're going to watch the voltmeter to get 13 millivolts. So I'm just going to reach around with the start button. See, right now we're at about 40 millivolts, so I'm going to want to turn down the zero pot till we get 13. And like I said, it's doesn't need to be exactly at 13. It can be plus or minus a little bit, but that's just right where we want it. Alright, then after we get the 13 millivolts, we'll just hit the stop button again. Now we're going to take the filling lance and put it in the test jug, and I'm just using a 4mm hole here, but you'll want to use a hole that's the same size as the hole in your spacer bar, because what we're doing with this test jug is actually replicating the actual unit that we're going to be filling, and you want to do that as closely as you can. So you can just take a piece of PVC with a couple ends on it, a couple caps, and then some kind of a brass nipple or something where you can connect it to the magnehelic. What the magnehelic does is it actually shows us what the internal pressure is inside this test jug, and it's a -2 to a +2 range magnehelic, and that's in inches of water. And what we want to do is have just a little bit more argon going in to the unit than we have vacuum pulling out. So how that's going to reflect on the gauge is anywhere positive. So we want it between 0 and 2. We don't want it negative. That means that there's more vacuum getting sucked out than argon going in, and that's a condition that we don't want. We want it just positive, so somewhere in this range. The nominal setting is 1/2. So that's where we're going to set it right now when we do this, and we're going to adjust that with this regulator on the back of the machine here. So we'll turn it to the right or clockwise to increase the argon pressure. Now I removed my red lead from the voltmeter, from the amplifier board, sorry, and I'm going to actually put this over here now on the PLC, and it'll be X12 on the PLC. You can also connect the red lead to the output screw on the amplifier board, but just again for simplicity, while I'm just doing this with one hand, I'm going to be just putting the clip on X12, and I'm going to leave my black lead on the common. I'm just going to leave it right there. Now I'm going to take my voltmeter and go from 2000 M to 20, and what that's going to do is give us a different range for our voltage readings. And again, my lance is still in the test jug, My MagnaHelic is still reading 0 because we haven't started the machine yet. And then as I start the machine, I'm going to take my screwdriver again and turn up the gain screw to adjust the calibration till the voltmeter reads 5 volts. And then if we look on the front of the machine, you'll notice that the meter on the front of the machine should say 100%. The meter on the front of the machine is a 0 to 5 voltmeter, and so 100% will be 5 volts back here. And so that's the front meter is mainly for the operator to see that the machine is working right. They are getting 100% fill or the 5 volt setting anyway, fill. And again, the sensor override switch is still in the up position. So I'm just going to reach around, hit the start button. We'll see that the MagnaHelic reading is in the negative right now, and so the way that we would adjust that is by turning up the regulator until we get a half inch on the MagnaHelic. And again, that half inch is just a nominal setting. As we get that half inch, now we can turn over and look at the voltmeter and wait for that to kind of settle down a little bit on a voltage. Pretty steady right there. So now we'll just take the screwdriver and adjust the gain screw till we get 5 volts. Okay, we got a 5 volts. Now we just want to look around on the front of the machine just to verify that the meter is showing 100%, and it is. So as we push the sensor override switch down, the machine will beep and the machine will shut off. It's like showing the end of the cycle. Definitely a loud beeper. That one works. That's what we like to see. So now that's calibrating the machine. We've gone through all the steps. The machine is now calibrated and ready to be put into production. And we would just take the filling lance and just put that into an actual unit and just go ahead and start it. Then that would start the filling process. On behalf of FDR Design, we'd like to thank you for supporting us by purchasing our equipment and working with us in that. And if there's anything that we can do to help you out, troubleshooting, repairing, if you just have general questions on argon filling, don't hesitate to call or email. We're always here to answer you. We've been around for 20 years. This is our 20th year. And like I said, if there's any way we can help you, please don't hesitate to call. Thanks.